Absolute value inequality solutions. This is an absolute value inequality. We're trying to graph the absolute value of x being greater than 0. Now, we have to recall what the absolute value of a number actually means. The absolute value of an arbitrary number is the measure that the distance, the value, is from 0. So when we read this, we're trying to describe numbers that are simply greater than, more than 3 units from the origin. We start at 3 and we shade the numbers that are more than 3 units from the origin. These are numbers to the right of 3. All of these shaded numbers are more than 3 units from the origin. Similarly, on the other side, we start at -3. These numbers that are shaded are also going to be more than 3 units from the origin. Since this is a strict inequality, we do not include 3 or -3. We're looking at all the numbers that are more than 3 units away from the origin, and this is the graph of our absolute value inequality. Let's note, we have an alternate way to think about this that will help for later problems. Let's consider the following. What this is a picture of is x being greater than 3 or x being less than -3. This right-hand portion is where x is greater than 3. This left side portion is where x is smaller than -3. Notice these shaded regions are on the same graph. We are taking the union here. The tip-off is that this has to be greater than 3. So if your absolute value is greater, it's going to be the union, an OR situation. This is helpful in the future. Keep in mind, if we graphed x is greater than 3, this is what it looks like. If we graphed x is less than -3, this is what it looks like. When we perform the union, we see both of these shaded regions on the same graph. Number 3. The absolute value of 2x is greater than or equal to 6. We're going to have to graph this. We're going to notice our inequality. This inequality is greater than or equal to 6. This means we're going to have a union. What's between the absolute value sign is 2x. So here's what we begin to do. 2x is greater than or equal to 6. Our 2x is going to be less than or equal to -6. We switch the direction of our sign and we take the opposite value. We're going to solve these inequalities and graph the union. and to divide both sides by 2, divide both sides by 2. We'll get our 2's to cancel. X will be greater than or equal to 3. We get our 2's to cancel. X is less than or equal to negative 3. Let's graph. The inequality on the right is describing numbers that are greater than or equal to 3. So let's shade these. These are numbers that are greater than 3. Use your bracket to communicate that we include the 3. On the other side, we have negative 3. And we're going to describe numbers that are less than negative 3. Those are numbers to the left of negative 3. Use our bracket to communicate that we include the negative 3. We have graphed the solution to this absolute value inequality. If they want interval notation, the left shaded region is described by negative infinity up to negative 3. The right shaded region is 3 to infinity, and we took the union. Number 5. The absolute value of x over 2 is greater than or equal to 4. Notice again, we have the absolute value being greater than or equal to. This tells us we're going to be taking the union. Our first inequality is x divided by 2 being greater than or equal to 4. The second inequality will be x over 2. And this is now less than or equal to the opposite of 4. We're going to solve these inequalities. Multiply both sides by 2. The 2's will cancel. We get x is greater than or equal to 8, or x is less than or equal to negative 8. Let's graph. The first inequality is describing numbers that are greater than positive 8. Numbers greater than or equal to that positive 8. First of all, numbers greater than 8 are to the right of 8. It's greater than or equal to, so we're going to use our square bracket to include the 8. Numbers less than or equal to negative 8, we start at negative 8. Numbers less than live to the left of negative 8. We include the negative 8 because it's a less than or equal to sign. That's our inequality. We have graphed the solution. The left portion, in terms of interval notation, is negative infinity up to negative 8 with a square bracket. Union, the right graph is 8 to positive infinity. This is our interval notation. Number 7, the absolute value of x being greater than negative 6. let's note. I'm going to say to you the following. Your solution set is all real numbers. What that means is every number on the real number line is shaded. What that would look like as a graph would be the following. Everything is shaded. Let's consider why. We're trying to describe numbers, by the way, that are bigger than -6 in absolute value. So let's remember essentially the following, that all numbers in absolute value are greater than 0 with one exception. What that means is the absolute value of x is positive for most of the values, but it's greater than or equal to every value for all x. The one exception is 0. The absolute value of 0 is 0. This is why we say the absolute value of x is greater than or equal to for all x. This statement guarantees that every number is actually greater than 0 in absolute value, with the exception of 0. This is our graph. Interval notation is -infinity up to infinity. Number 9, the absolute value of x minus 3 is greater than or equal to 2. Notice again, the absolute value is greater than or equal. This means we have a OR situation. We're going to ultimately take the union. X minus 3 is less than or equal to -2. We're going to solve and graph each linear inequality. Then we'll take the union. Add 3 to both sides for each inequality. We get x greater than or equal to 5. X less than or equal to 1. We're going to form the union when we graph. We're going to describe numbers that are greater than or equal to 5. Numbers greater than or equal to 5, we should begin by saying numbers greater than 5 are to the right of 5. This is what we shade. Our square bracket indicates that we include the 5. Numbers less than or equal to 1, we start by saying numbers less than 1 are to the left of 1. We include the 1 because it's a less than or equal to sign. You have to use the square bracket. What you're looking at is the graph of the union of these two simple inequalities. Written in terms of interval notation, we're going to describe the left piece by -infinity up to 1. Be sure to use the square bracket because of the fact that we include the 1. use a square bracket for the 5 because we include the 5. This is our interval notation. Number 11. 3 times the absolute value of x minus 8 is greater than 1. We're going to add 8 to both sides because we're going to have to solve for the absolute value. Three times the absolute value of x is greater than 9. Divide both sides by the 3 and cancel. We get the absolute value of x is greater than 3. Notice again, the absolute value is greater than, which means we have the OR situation. We're going to take the union. X is greater than 3. X is less than or equal to negative 3. We're going to need to graph and form the union. The first inequality is describing numbers that are greater than 3 units from the origin. Those are numbers that are to the right of 3. We don't include 3 because it's a strict inequality. We have to put our parentheses. Numbers less than or equal to negative 3, on the other side, we first begin by describing numbers that are less than negative 3, and those are numbers that live to the left of negative 3. Again, we use a parentheses because we do not include the negative 3. This is numbers less than negative 3. Interval notation describes the left shaded region as negative infinity up to negative 3. The right region is 3 to infinity. This is number 11. Number 13. Negative 2, absolute value of x plus 4, plus 1 is less than or equal to negative 5. We're going to have to solve for the absolute value. We do this by subtracting 1 from both sides. Negative 2, absolute value, x plus 4 is less than or equal to negative 6. Divide both sides by your negative 2. Cancel the absolute value of x plus 4. Since we divided both sides by a negative, we have to switch direction of our inequality sign. Negative 6 divided by negative 2 is positive 3. We're going to notice something important here. Our inequality sign is greater than in relation to the absolute value. Again, this is the union. We have x plus 4 greater than or equal to positive 3, or x plus 4 less than or equal to negative 3. We're going to solve by subtracting 4 from both sides. We get x greater than or equal to negative 1, x less than or equal to negative 7. We're going to take the union. We're now going to describe numbers that are bigger or equal to -1. Numbers bigger than -1 live to the right of -1. We include the -1 because it's a strict inequality. Excuse me, it's actually greater than or equal to. It involves equality. The second inequality describes numbers that are less than or equal to -7. Numbers smaller than -7 live to the left of -7. We include the -7 because it involves a condition of equality. These are less than or equal, greater than or equal signs. What you see here is the graph. Interval notation for the left region here is -infinity up to 7, and then 1 up to infinity. This is my union. Number 15. The absolute value of x is less than 2. Let's go back and think about what the absolute value means again. The absolute value of x is the measure that x is from the origin. We're measuring distance. How far? How far numbers are from the origin. What this is saying to us is we're going to have to describe numbers that are smaller than, less than 2 units away from the origin. Well, numbers that are less than 2 units from the origin, notice on our real number line we don't care about the direction. We don't care about to the right or to the left. We just care about what's happening around 0, the origin. So I want to shade all the numbers that are smaller than, less than 2 units from the origin. We're going to use our parentheses because we have a strict inequality. They must be less than 2 units, smaller than 2 units from the origin. That means we do not include 2 or -2. Let's note, this is the between situation. In other words, if we were to describe what we just shaded in terms of set notation, give it sort of a description, the numbers that are shaded are all numbers that are between -2 and +2. This is what we're going to use for the absolute value being less than 2. I'm also going to point out something else. Let's note, the absolute value of x being less than 2 can also be used or thought of as an intersection. X less than 2 and x greater than -2. Notice, if we were to graph x smaller than 2 with x greater than or equal to -2 and find that intersection what you're going to see again is this middle region is shaded. This is where they intersect. This is where both graphs meet. This is what's shaded in both. It's where they overlap. This is the essence of what we mean by the intersection. These are tools that we use to solve every absolute value of x being less than a particular number. Number 17. The absolute value of 3x is less than or equal to 9. Because we have the absolute value being strictly less than, we can use the between situation. Here's what it looks like. Negative 9 is less than or equal to whatever's between the absolute value, which is just 3x. 3x less than or equal to positive 9. I'm going to solve for x. I could solve for x by dividing the middle term by 3, the right term by 3, and the left term by 3. What I end up with is negative 3 less than or equal to x, which is less than or equal to positive 3. This is the between situation. I'm going to shade numbers that are between negative 3 and positive 3. Here's what it looks like. Start at 3, indicate where negative 3 would be, and shade numbers that are simply between these two. Because we have less than or equal, because we have the condition of equality, we include the negative 3, we include the positive 3, we use the square brackets. In terms of interval notation, what we just shaded was everything between negative 3 and positive 3, including negative 3 and positive 3. Set notation simply requires us to use the format, the set of all x, such that we now have to give the description. Here is our description. And we're done. Number 19. The absolute value of x minus 1 is less than 8. We're going to notice that we have the absolute value being less than. We're going to use the between situation. We can solve for x by adding 1 to the middle, 1 to the right, and 1 to the left. We get negative 7 less than x less than 9. These are numbers that are between negative 7 and positive 9. We're going to graph. Negative 7 is to the left with all the negative numbers. Positive 9 is to the right. We're going to shade the numbers that are between negative 7 and positive 9. This is a strict inequality because we have less than, parentheses, parentheses. Interval notation would be negative 7 up to positive 9. Set notation would be the set of all x such that I need to now give my description. Here is the description. negative 7 less than x less than 9. You are done. (21). The absolute value of x is less than negative 2. This never happens. That's because the absolute value is always positive, with the exception where x is 0. The absolute value is usually positive. Positive numbers are never less than negative numbers. Even 0 is never less than negative numbers. What we say is that there is no solution. Set notation will describe this as the empty set. If you had to shade numbers on the real number line that corresponded to no solution, what you would actually see is what you're looking at right now. You'd see a real number line that has nothing shaded. (23). The absolute value of 2x minus 1 is less than or equal to 7. Notice we have the absolute value and less than or equal to. This is the between situation. We can solve for x. Add one to the middle, one to the right, and one to the left. We end up with negative 6 less than or equal to 2x less than or equal to 8. Divide both sides by 2 to solve for x, and the middle, divide by 2. We end up with negative 3 less than or equal to x less than or equal to 4. The between situation. Let's graph. Negative 3 is to the left, and positive 4 is to the right. We have to graph numbers, or shade numbers, that are between negative 3 and positive 4. We put our brackets because we include negative 3 and positive 4. Set of all x such that in set notation we need to remember the description. This is our description. Negative 3 less than or equal to x less than or equal to 4. Interval notation is from negative 3 up to 4, including negative 3 and 4. (25). 4 times the absolute value of x plus 2 is less than or equal to 12. We have to solve for the absolute value. Start by dividing both sides by positive 4. We get the absolute value of x plus 2 being less than or equal to 3. Notice absolute value less than. This is the between situation. Negative 3 is less than or equal to x plus 2 which is less than or equal to positive 3. We can solve for x. We subtract 2 from the left, from the right, and from the middle. Negative 5 less than or equal to x, less than or equal to positive 1. Let's graph. Negative 5 is to the left of 0, and 1 is to the right of 0. We're going to have to shade numbers that are between negative 5 and positive 1. Because these are less than or equal to signs, we have a condition of equality. We include the negative 5, we include the negative 1. Interval notation says start at negative 5, end at 1, include the endpoints negative 5 and 1, which is why we use the brackets. Set of all x such that if they ask for set notation, we need a description. In orange, we have our description. Number 27. Negative absolute value of x plus 6 is greater than or equal to negative 4. On first glance, we might falsely conclude that this is the OR situation because of the fact that we have the absolute value of x being greater than. That's not really the case. We have this negative 1 out here multiplied to our absolute value. What that means is we have negative 1, absolute value of x plus 6 is greater than or equal to negative 4. We can divide both sides by negative 1, but remember to switch your inequality sign. We have x plus 6 is less than or equal to positive 4 in absolute value. Absolute value less than, and this is the between situation. We can solve for x. Negative 10 less than or equal to x less than or equal to negative 2. We're going to graph. Negative 2 is to the left of 0, and negative 10 is further to the left of 0. We have to describe numbers that are between negative 10 and negative 2. Since it's a strict inequality, pardon me again, it's not a strict inequality, we have less than or equal, conditions of equality. We got to use these square brackets. Interval notation is from negative 10 up to negative 2, including negative 10 and negative 2. Set notation, the set of all x such that we need a description. This is my description. This is set notation.